Good day and welcome to Injection Molding Process Solutions. There are basically 5 inputs to injection molding a product, and that's part design, material, mold, process, variables, and machine. These 5 areas encompass making up the molded parts. Any one of these 5 areas, you could have a problem. This presentation is designed around troubleshooting, and the areas we'll be looking at are probably the most common problems you'll see in injection molding, if not all of them. And that is when you start up a process, you get non-fills and shorts, jetting, flow lines and poor wells, poor gloss, dullness, rough surface, flash, excessive shrinkage, warpage, splay and silver streaks, sink marks, internal voids, burn marks, parts or sprue sticking, and discoloration. As I said, this is a troubleshooting injection molding presentation, and there's a full battery of troubleshooting charts that focus on the 5 areas we just discussed. The way the presentation flows will demonstrate a problem of what you see listed here, a non-fill, a short, a jetting, in 2 slides, and discuss those slides, and then go on to the troubleshooting charts. You'll see highlighted yellow portions on the troubleshooting charts. These are the areas we'll be discussing for time purposes. Non-fills and shorts, as you can see, this is a common problem. I probably see it quite a bit on starting up new products and everything, or new molds. Once again, these troubleshooting charts are very good for brand new molds or prototype molds to try to focus in on what the problem is. We have one where it's magnified 50 to 1, where you can really see the short. The next slide is what we call backfilling or race tracking as far as non-fills. And what's happening here is the material is racing around the thicker area on the outer edge and getting to the end of fill before you can fill over the center. And this is caused because that outer section is thicker than the thin section, and the material just won't flow across that screen. A couple ways to get rid of it is thicken up the screen area or thin down the race tracking area until the screen fills out first before the outer edges fill out. Now, if you take a look at the troubleshooting chart, areas where there's a problem, like we'll look at molds here, increase the size of the sprue, runner, or gates. This is often a problem. You just can't get enough material into the cavity quick enough. It could be because the sprue's too small, maybe the runner system's too small, the gate's too small. This is a common problem. Check cavity vents for blockage or measure them. Over time, as the molds close and close and close, you're closing a lot of tonnage on these molds. The vents will eventually crush. Moving on to process, get the highlighted area, increase your injection pressure. A lot of times you might not have enough pressure because it's a new product you're starting up. You might have to jack up the pressure, as well as the melt temperature in the barrel. Most materials, you can get a processing sheet for it. Gives you the range you should be running the material. You should be probably about in the mean of the range of processing melt. This way you can move up or down, but you want to make sure you're at the right temperature. Move your transfer point to 90 or 98% filled. If you haven't filled out the part at 90 or 98%, the chances of filling it out on pack and hold are pretty slim. So you have to fill out most of the part at high injection speed as well as high pressures, and then go into pack and hold. We say 90 to 98%. If you're running real small parts, you probably want to fill at 98%. Small or thin wall parts. If you're running fairly large, thick wall parts, you probably want to fill at 90% because you want to allow the air and the gases to get out of the mold. And we'll discuss that a little later on. Increase your back pressure, 25 to 50 psi's. Most machines have about 50 psi's built into them already, although it may not register it, but it's already built in. This will ensure that you have a good cushion on the front of your screw. Jetting, it's not that common a problem, but it is a problem. In some cases, generally in new molds, you can see some little squiggles in the center of this part from the runner gate end starting to go across. And this is caused by material just flowing out and not hitting a wall. The material continues to flow, but that string of material that went out has set up, and now you're molding around it like it's an insert. The next one gives a better demonstration of jetting. As you can see, this is the double gated clear part. You can see the material, how it flows out, and then all of a sudden, just the way it went out into the mold, it's starting to set up around it. Like I said, it's usually a common problem on new mold startups. Some of the things you can do is put an after radius at the gate area leading into the cavity. What this helps is create turbulence as the material is flowing down just before it gets to the gate. It creates some turbulence, so it causes the material to go through the gate and hit a wall. The material has to hit a wall for it to set up so you don't have this jetting problem. In some cases, you may have to review your gate location and ensure that you make immediate contact with the cavity wall. You may be really gated into a thick area. Of course, you should go from thick to thin, but if you're not making a wall, you might have to move it to a little thinner area. I've even seen customers leave the gate where it is and put like a little pin right in front of the gate area or just in front to force the material to hit a wall. In this way, it starts setting up on the A and B side of the cavity because material flows up the center of the part and not outside portions. Poor flow, poor wells. As you can see, this is a metallic color. This is what we call our B12 mold. This is our mold. You can see the flow lines. This actually occurs because of the metallic color itself, that you can see it so clearly, because as the flow fronts come together, the metallic aligns itself differently. It's a flake, and then it's aligned differently, and then sort of reflects the light a little differently. That's why you're seeing that flow line so distinguished with the color. Here's a blown up portion of a well line. Good demonstration of what you so often see. We have check the vents for blockage or measure them. It's very critical that the venting, you're going to see it almost on every slide. That mold closes, there's air in the cavity. And you have to get the air out of the cavity to get the material in the cavity. And that's where the air goes, that's in the cavity, through the vents. As well as a lot of gassing that takes place because of the material through shear, so you have to allow all that air and gas to escape through the vents. So it's critical that your vents are always up to snuff. As a matter of fact, I just recently ran into a problem where a customer was running for 3 years, making wonderful parts in a glass reinforced product, nice glossy finish. Over 2 or 3 months, they couldn't get the gloss back. As they checked the vent in, they found the vents had crushed like 8/10, crushed down, so they had to reopen the vents back where they belonged to about 1/1000. Lo and behold, once again, they had nice high glossy glass reinforced product. Check for the core shifting. No matter how big the core is in those molds, if they're not anchored properly, the core will shift. Will shift the core, so you're allowing material to be one side of the core, then the other side, let's say 80 thousandths to 60 thousandths, when you're supposed to have an equal 70 thousandths or equal 80 thousandths on each side of the core. So you will have a very distinguished well line there on the thinner side. And in some cases, you may have to add flow leaders at the weld area. And what this is just leading material to that area, sort of cut a half round into the mold. And this is done a lot with large parts, a lot of automotive parts. As far as processing, you want to increase or decrease your injection speed. If you're going too fast with your injection speed, you're not allowing the air and the gas to get out of the mold, so you may be running too fast. If you're running too slow, then material starts to set up and you can't get to the end of fill to push all the air and the gases out. Poor gloss, dull, or rough surface finish. What you're seeing here are what we refer to as sails. They're used, they're on the side of the car to help hold your mirror housings. Basically, these are the same part. Doesn't look it, but they have the same part. They're textured. The part on the left was molded properly. The part on the right was molded with a cold mold and underpacking. When you have a textured product, or even high gloss products, you've got to pack it out to get the image of the mold. And you have to do it with heat and making sure you're packing out, or you won't get the material in those little cracks and crevices, and it'll come out looking high gloss like it is. And even with high gloss surfaces, you still have to pack it out to get the true, nice gloss appearance. Here you're looking at plaques. It's a 35% glass reinforced nylon. And what you can see here is that grayish white area is actually glass coming to the surface. If you inject the plaques at 3 seconds, you can see quite a bit of glass on the surface. Injecting the plaque at 1.5 seconds, glass looks much better. At 0.4 seconds, it's what we call burying the glass. What tends to happen is by injecting it fast, you bury the glass and force polymer to the surface of the cavity. This is how you get a nice, glossy, glass-free part when you're running glass-reinforced products. To improve poor gloss of dull areas, improve the mold surface finish. Clean the mold or polish it. In a lot of cases, even with textured parts, material flows across. Your gas will build up in these little cracks and crevices, and you have to clean it up. As far as highly polished parts, the more you polish it and clean them up, better off you are. And once again, you got to clean those vents once in a while, allow the air to get out. Check your non-return screw valve, because if the check valve is slipping a little bit, it's not allowing you to pack the part out properly. And increasing the mold surface temperature, this always helps to get the most ideal finished molded part. It's easier to duplicate whatever you have on the cavity. Pre-dry the material. I hate to use a higher temperature, but maybe a longer time. Get it bone dry, basically, depending on the material you're running. But I've seen this with all materials. No matter what material it is, if you dry it, it usually generates a better looking part. I won't say sometimes you might have problems that won't solve the problem completely, but it'll give you a better appearance on the product, on the molded part. Flashing. This flash here is a result of, not enough clamp force on the mold. And this is actually a potting line flash down into the taper area. This is a flash that we created in our lab. This is a accelerator pedal in nylon 6/6 glass reinforced product. And if you can see over to the left at 620 degrees F, that's too high for this material as far as the melt temperature. But you can see quite a bit of flashing taking place. It's just flowing in unbelievable. And if you look at the 590 melt accelerator pedal, there's still a little flash on the left side of it, a little better. This is somewhat extreme for the melt. 590 is the high end of the melt, which you don't really want to use if you don't have to. But at 555, right in the mean of the melt, without changing anything else, you see a flash-free part or accelerator pedal. One thing to check is the square projected inch of the molded part. The rule of thumb is for every square projected inch you're going to be molding, you need 2 tons to keep it closed. Now, this is the rule of thumb. However, if you have a very thin wall, deep draw part, you could be up around 4 to 6 tons per square inch. Check the machine hydraulic clamp and injection. In some cases, your hydraulics might be not functioning properly, so you're not getting enough clamp at the clamp end, or could be that your injection is just moving in too fast when it shouldn't be. You get no control. It's always good to check your hydraulics and make sure everything's working properly according to what the gauges read. Transfer the pack and hole sooner. In other words, you are packing the whole part up and not moving over to transfer, so you're using excessive amount of pressure to fill the mold. Basically, if you use full machine pressure to fill a mold, either there's something wrong, the reason the material won't go in, but the material does get into the mold, you can probably flash any mold you run with full machine pressure. Check the melt temperature as we demonstrated. You want to basically run in the mean of the melt and move it accordingly to what you might be running. Excessive shrinkage and warpage. This is a wheel cover. Top wheel cover is 100% glass reinforced nylon 6 product, and you see a glass mineral product. The reason the glass reinforced product warps so much is because the glass lines up, what we call lining up in the flow direction, as these line up end to end. Because glass is cylindrical glass. It's long and thin, so it lines up from end to end. Glass does not shrink. It's the polymer that shrinks. So as it lines up from end to end, and you have several of these things lined up like a railroad yard, all the railroads are lined up, and you have the polymer between them, and it's the polymer that's shrinking. That's why you get so much warpage taken with glass reinforced products. But when you go to glass mineral, you see there's less warpage, and with minerals, 100% mineral product, there's absolutely no real warpage taking place. And that's because mineral is a cube. So as the mineral goes into the mold and the polymer that lies between each cube, the distance is basically the same. So you get very even shrinkage. Here's a connector. Similar problem, you can see the open gap on the left-hand part where it's open because due to warpage, and here we're using a 20% glass reinforced PVT product. The way we got around it was to use a 20% glass bead product. Glass bead, what it is, it's a sphere. So the polymer that lies between each sphere is equal distance, so you get even shrinkage taking place. Improve your cooling system or insert with a special metal. That's the biggest thing as far as shrinkage and warpage right off the get-go, is to make sure you get good cooling or able to get cooling in certain areas of your mold. In a lot of cases, you may have to put in special materials that draw the temperature down quicker in your mold. And this is very effective. It works quite good. Core out thick sections. A lot of times your areas might be too thick. You have to core them out in order to minimize the shrinkage that's taking place. Reduce your knockout speed. This is taking the part off the B half of the mold, the KO system. If you're ejecting something very fast, you need the undercuts to remove the product from the A half of the mold to the B half. If you eject it too fast, you could be warping it on injection. So if you slow down your ejections, the KO will generally, in a lot of cases, minimize warpage taking place due to KO. And in some cases, you may have to use a shrink fixture. I just recently worked in a project where they needed to use a shrink fixture because there's such a thick section, and I had to chill the shrink fixture down to about 32 degrees, and the part stayed on the shrink fixture for about an hour. Surface splay, silver streaks, the next area to look at. This is the silver streaks you see in this part is due because of moisture in the pellets. So common this is a problem. We see this in the field a lot where the dryer or the decandescent beds aren't working properly and the material is got moisture in it. This is a very, very common problem. Probably one of the first things you want to go to when you see something like this, that you get too much moisture in the material. We also recommend check the moisture of the material if you have a moisture analyzer. We recommend you check it incoming and while you're processing the material. It's an excellent tool. Here we have white streaking or heat splay because of too much heat in the material. As I said, the material creates a lot of gassing and volatiles. If its temperature is too high, then it'll probably show up in your product because you get more volatiles taking place as you're injecting the product. Areas to focus on. In some cases, you could get streaking because you got water leaks in the cavity. It could be a little insert. Maybe the O-wing got pinched, sheared for some reason. You're getting a little drop of water taking place maybe every other shot. See, this is a very difficult thing to troubleshoot too because it's not happening all the time in some cases. The water lines are above the mold, could be leaking down into the cavity. Check heater bands and controllers and thermocouples. Make sure they're working properly. A lot of time, if you put the wrong thermocouple wire, you're going to get the wrong read back to your thermocouple controller. You don't really have the right reading, so it's important you use the proper manufacturer and recommended equipment. Check hot runner system manifolds. This is an area there's quite a bit of problems in hot runner manifolds, especially if it takes place in new molds. When I was in manufacturing, I used to take, when I got a new mold in, I would take it, put it on the bench, take it apart, and the controllers that I'm using for that mold, I would set them up and check the temperatures of the hot runner system, the hot drops, the manifold block itself, and make sure everything corresponded to the proper controller as well as giving me the proper temperature or what is the relative temperature it's showing. Decreased melt temperature, we demonstrated that, what that can do for you. You want to dry the material, check the condition of your dryers and hoses and decandescent bed. And also check the size of your dryer. I had this problem take place at a customer where they had two big dryers drying several hopper dryers. And this worked fine for 9 months, but in the middle of summer where it got very humid, the dryer just could not keep up with maintaining dry material at the high humidity levels of the summertime. The time of the year is very critical in some cases. You might have to add more drying capacity in your plant. Sink marks, this is a very common problem. You can see this. This is visible because of ribs. A lot of time where there's ribs, because the rib is thicker, this is why you get the shrinkage. You get more shrinkage taking place in the thick area. Once again, you can see the sink marks on the left. It's kind of thick in that area, and the sink marks are showing through on this grill. This is an actual grill. The only way you're going to get rid of that is by coring it out, unless it's being underpacked. Some cases, you might have to redesign it, relocate the gate near a heavy section. As I said, you want to basically try to go from thick to thin, or you may have to run a flow leader to a thick area. Redesign part for uniform wall thickness. This is kind of nice, but whether it'll take place, sometimes you can't always do that. This should be considered in the product design stage. Increase hole temperature, pressures. This helps a lot of times. It's what tends to happen on pack and hold at a lot of customers, and I've seen this, they don't have enough time on their pack and hold to completely pack out the part. In other words, the gate is not frozen off. One way of doing this is just keep lengthening the time of your pack and hold and weighing the part up. But even in the smallest parts, it's unbelievable. 8-cavity molds, very small parts. You may think you're sealing off the gate in 2 seconds, but it may take 5 seconds. And this is very critical to getting, a sink-free part. One thing about a semi-crystalline material like nylons or PBTs, they set up much faster than amorphous-type materials. Amorphous-type materials will continue, if you keep pressure on it, you'll continue to put material in the cavity for a very long time period. Decreased melt temperature. If your melt's too hot, then you're putting too much heat into the material. And I've seen this work real good as far as sinks, and also help with flash as well, as we demonstrated earlier. Increase your cushion. I like a lot of cushion. I don't like to cut it down so it's very minute to, 1 millimeter or 0.5 millimeter. I like, smaller machine, all right, 2 or 3 millimeters. A bigger machine, give me a 1/2 inch, 3/4 of an inch. There's nothing wrong with having that much cushion on the machine. You're still using good molding practices. Like I said earlier, with the hydraulics, the machine might be off a little bit in the adjustment. Internal voids. As you can see here, this is an internal void to the thick section. Why that you have an internal void is because the material in this thick area, you mold the part, and the outer skin and the other areas, the thin areas, are set up. They've crystallized. However, in the thin area, you have a lot of heat, so the material starts to shrink, and that's what it does. It shrinks away from the inside wall because it's so hot, and actually the material is probably still molten when you take this part off the mold. Internal voids, a bubble. Once again, this is due to air entrapment, and this is caused a lot because you're just not getting the air out of the mold. You're going to have to add vents or slow down your fill speed in order to allow the air and gas to get out before you fill the end of the part. Part design, relocate the gate near a heavy section. This will help in thick areas, but sometimes you can't always do that. Redesign the form with uniform wall thickness. Increase your hold time and pressure. We discussed that on the previous slide. Decrease melt temperature, very similar. Some of the problems are very similar to the previous troubleshoot slide. Decrease injection speed, which always helps, like I said, to get the gases out. Increase cushion, increase your back pressure. Dry material, like I said, you got to have dry material in order to make a good product in all cases. Burn marks, this is at the end of the flow where your material comes together. Basically, this gassing is taking place because there's no vent in this area. There's no venting in the last place to fill. So you're getting all this gas entrapment and you're molding around it. Similar situation here. You can almost see it looks like a short shot. And that's because all the air is in there and you're just molding around air and gases. Both these parts are ABS parts. Clean the vents. Check the vents for blockage or crush vents. As we stated earlier, very critical thing. My saying is you can't vent enough. Increase vent size or the number of vents. Change gate location. Increase clamp pressure. Decrease pressure. Sometimes you have a smaller mold and a big press. You might have just too much clamp. You're not allowing the mold to breathe. Decrease injection pressures and speed. Decrease melt temperature. This will all help with the gas burning because you're allowing the air and reducing the amount of gas taking place. And change your transfer position. Once again, if that transfer position is too close to 100% filled, you're not giving the vents enough time to work to allow all the gas to get out of the cavity. Part sticking. This is ejector pin marks because the ejector pins are too small to eject this fairly large part. Once again, this is a wheel cover. The product below is being deformed because we're overpacking it and it's sticking to the core. The product on the right is because of excessive undercut. This happens a lot, and sometimes to remove the product from the A half to the B half, we have too much undercut, and then when we eject it off, well, we break pieces off because of the undercuts being too deep. Check surface finish and polish in the direction of release. This is very critical. You should always polish in the release direction. In other words, the molded part is being taken off the mold. Add or increase undercuts. Remove nicks and burrs from bosses, cores, and cavities and sprue bushings. This happens quite a bit in sprue bushing areas where there's a little nick that might take place for whatever reason, causes the sprue bushing to stick quite a bit. And check for adequate reverse taper on sprue pullers. If you don't have enough reverse taper there, you won't be able to pull the sprue out of the sprue area. Check between nozzle seat and sprue bushing. This is a common problem because you could have a perfect seat taking place with no burrs or rough spots in that area. Ensure that the nozzle orifice is smaller than the sprue orifice. Increase cycle and cooling time. A lot of times this will help solve the problem. Earlier you were trying to pull the part out too soon so the material hadn't set up. And if you have to lengthen the cycle, this is okay. But if you're lengthening it and you know the material is set up, then there's a problem somewhere else. So you have to focus on where it might be. You know, it could be like one of the things up above as far as the nozzle seat. I've seen it where the nozzle seat is poor, but if you lengthen the cycle, you get the sprue out. Decrease mold temperature. Maybe the mold's running too hot. Decrease hole pressure. Change transfer point. Once again, you might be too high in your pressure. You're just putting too much plastic in there, probably flashing some areas, causing things to stick. Part discoloration, color streaking, non-homogeneous distribution of color. What you see here, the color is not really mixing in properly in the barrel, and so this is what you're getting in the finished product. It's not a good blend of colors. This could also be taking place with the type of concentrate you might be using to develop the color. Maybe you need a lower melt flow in the concentrate to get a good dispersion. Once again, this color streaking caused by dead spots in the hot runner system. In other words, material is getting hung up in your hot runner system because there's a cool area in that area. And this could actually be some kind of burning taking place as well. Looking at the troubleshooting chart, remove excessive grease and oil from the surface. A lot of times, you might get some toolmaker that over greases, and it's good, but it could create problems for you in the molding floor. If there's grease behind inserts and things like that, that could leach out for days upon end. You might have to pull the mold out and re-clean it. Also check the ejector pins for excessive grease. The same thing that will happen, it will just leach forward for hours and days. Purge the cylinder with a purging compound. A lot of times this will work, but if you're going from a colored product to a clear product, just as well to pull the screw out and barrel and clean it. Because I know a lot of places that are really good at this, and what they do is they have a screw ready to go, and they just pull the screw out, and the barrel looks pretty clean. They throw the screw in. Check the check ring design. Sometimes if you're using a ball check, it could create problems with some materials. In some cases, a ball check might give you better mixing of the material to give you better colors. Decrease melt temperature. Once again, we brought that up. If the melt temperature is too hot, you're going to see possible streaking taking place because of heat. Well, one of the final slides is the highest frequency of processing problems as observed by BSF technical personnel have been attributed to. And basically, what we're saying here is that we probably have like 200 years experience with all the technical service people we have on board. Every time we go into a customer who's having a problem, and these are listed more or less in priority, this is what we see as their problem. So in other words, improved drying of material. We've discussed that a little bit, that the material has to be dry. This is probably one of the most common problems we see. Damaged nozzle tips. If a nozzle is not the right size or it's damaged, and it's going to shear. Malfunctioning of nozzle heater bands. This is a very common problem. I see it out there a lot. Worn or non-return check valves or check rings, the end of your screw, this should be checked. Good predictive maintenance should be established in order to check your non-return valve. This is not working. You will not be able to make a good product. Improper velocity profile. Once again, we discussed this from 90 to 80% fill on first injection phase. This is very critical. You want to fill it as fast as you can without creating too much gassing. and then go into pack and hold to make an ideal quality product. Insufficient pack pressure, another area to where there's just not enough pressure or time, make sure the gate has been sealed off. Mold venting, we focused on that a lot. Gate location, and we focused on that, and that's very critical, especially in the design stages. If you have the opportunity to get in there and make your opinion known, that's very critical too. The final slide is a snapshot of a troubleshooting chart. I mean, it's a one-pager, a little easier to use, while a little easier to carry. Let's put it that way. This is also for your use as well. Thank you.